Hello, today I'm going to walk you through Section 2, Active Learning, which is a second element of effective instruction. When talking about active learning, you may have the question, what is it? What is active learning? Active learning is anything that course related that students in the class session are called on to do other tasks or other things than simply watching or listening to a lecture or taking notes. So active learning, in other words, active learning may refer to the way of learning that students use their energy, their own thinking, their own idea, or get involved into the learning or in the classroom. In order to help you to see how to develop the lecture classroom within the active learning environment, one of the physics professor named Eric Masur, he's a physics professor from Harvard University, and he's very famous, a very big name internationally in terms of using active learning in a big lecture classroom. So let's take a few minutes to watch part of his lecture class, and I would like you to observe or carefully observe about the environment of the classroom, the role of the teacher or the role of the instructor. What did Eric do in the classroom? And the behavior or feeling, emotional of the students in his class. And then we are going to come back and discuss after the end of the video whether or not it's different from the lecture class that we usually see in Thailand, and can we do something like this in our own lecture class with the same learning style of the Thai student? If we want to have active learning in our class, what we are going to do. But before discuss about this, let's see the video of Eric Masur classroom.
Which you can hopefully see. Whoa, that's a bit much, but you get the picture. You see that they're rotating in a clockwise sense. So the question is now, what is happening here? Is it the positive ions that are causing this motion and carrying along the pollen? Or is it the negative ions, right? If I turn off the electric field, then there is no electric field, nothing is moving. This will come slowly to rest. As I turn on the electric field, the ions here will be accelerated in the electric field. As they start moving in the electric field, they feel the effect of the magnetic force, and that is what makes them rotate. So you have to see whether it's the positive or the negative ions or both that carry the pollen along in a clockwise direction. So take a minute to think about it, and then enter your votes using the PRS system. And no talking yet. Come up with your own answer. Okay, I still need 10 to 20. I still need about 10 to 20 votes here. So please enter your answers. We have a disagreement clearly here. About a 50-50 split between two answers. I'll let you guess which ones. So turn to your neighbor and see if you can, and remember, finding one correct answer, for instance, the negative ions, doesn't mean that the positive is necessarily true. So you have to really try out both. Go ahead, check with your neighbor and see if you can agree.
From north to south, but so it's going down, right? So we have basically an E field that points in.
Okay.
A positive particle moving this way means a current that way, right? A negative particle moving that way means the current same way.
That way, yeah.
Right, that's interesting. So what does that mean about the force on that?
It's the same.
I cross B.
Does it radiate? Does it mean it's radiating out?
I cross B, so I is inward, right? B is into the plane of the drawing, right? So I to B. Wait, B is down, sorry. So I, and let's look at the bottom, right? I is towards the center, up, right? And B is down, so the force at the bottom would be clockwise.
Same way.
Can you do that one more time?
Okay.
Yeah, you're
So positive ions, the positive and the negative ions both have a current that goes inward, right? So let's look at the bottom of those two circles. The current goes up, right? Up. The magnetic field is into the plane of that drawing, right? Into the plane of that
How
screen.
are you doing your hand again?
So I current up,
You're looking at that. Okay,
magnetic
so the
field
current's up, magnetic
into the
field.
screen.
Okay.
Force at the bottom towards the left.
Okay.
At the top, you know, we have current down, magnetic field still in. So we have a force towards the right.
Right, yes.
So, and the fact that the current is both up for negative and positive particle means they're both going to rotate clockwise.
So it was
How can both particles? Because shouldn't they be moving in opposite directions? And the current's moving in opposite.
It's kind of hard to visualize because it's three-dimensional.
But how do you know how to weigh the electrostatic and magnetic forces? Like, how do you know which one is greater?
Well, you don't really
So
need
please
to
enter
know
your
which one's
answers.
greater because one is pointing in the x direction, the other one is pointing in the y direction. So you have to superimpose them to get the direction of the force, right?
See if you can come to some agreement. There's about 20 seconds left, so enter your answers. Okay, well, let's see. Okay, so we started with about a 50-50 distribution on choices 1 and 2. And right now, we're at 1/3 for 1, 1/3 for 2, and 1/3 for 3. Clearly, we need to do some more thinking and talking about that. So I've started by making a drawing here, a top view of the bottom of what we see on the screen here. So that's the inner cylinder. This is the outer cylinder. Which way does the electric field point? between those two cylinders. From plus to minus, so that means upwards at the bottom and, slightly inwards on the sides, but we're going to concentrate on this area right here.
So, you can realize that Eric doesn't tell any knowledge to the student. The role of the instructor is to ask questions, to find a short activities or the problems for the student to discuss. And you can realize that at the beginning, he starts to let his student, a particular student or each student think on their own and then send the answer to him through the clicker. So by this time, he realized that how many students understand about the concept that he's going to teach and how many students still get confused. And you can see that when the students are asked by him, they try to think on their own automatically. Yes, this may not happen in Thai classroom because we didn't use this technique or we didn't let our students do this way of thinking before. But as I taught in the previous session that learning style can be changed. So if we use or provide more opportunities for students to think, after you engage them with the problems, they're very excited and let them think and share their own idea. You provide this opportunity quite often. Your students are able to do that, similar to the students of Eric Masur classroom. And you can see what Masur did. He didn't tell the right or wrong answer. He didn't tell or get the student, have the student get any senses of whether or not they give the wrong answer or right answer. They didn't, the instructor didn't make the shame on the student at all. This is the way how to make the trust environment in your classroom. If you want to have the active learning happen in your classroom, you need to be careful that you don't provide right or wrong or let your student feel shame or feel unable or stupid within or amongst classmates. This is very important. After Masur let the student think by their own, they ask students to share with neighbor. So they can share with neighbor on the back or side, who sit on the side. Share the idea and discuss. And at the end, he asks the student as a whole to make a decision or share or discuss the idea again. So he have in 8 minutes of this videotape, you can see that he provides many opportunities for students to think. At the beginning, he starts from let students think on their own and then share with the neighbor, and at the end, think as a whole class. So the students were set into the environment of sharing, discussing, and thinking. This is the active learning. So students use their energy, use their idea, use their knowledge to share and involve into learning. So this makes students feel like this is their classroom. So you can see that nobody fall to sleep, but actively learn or involve into any task that Eric asked them to do.